Hi and welcome to another chemistry lesson. This is actually a combination of chemistry and electricity called electrochemistry. And the first thing that we're going to look at is the concept of redox reactions. Okay, what is a redox reaction? Well, the read stands for reduction, and oxidation. So it's reduction and oxidation of compounds. So what is a reduction? What is reduction? Reduction is the process of an element or compound that gains an electron. Now, I don't like the name because you're gaining an electron and yet you are being reduced. So something that is undergoing reduction is being reduced. Okay, so I suppose we can think of its positive charge is being reduced by gaining electrons. So gaining electrons means you are undergoing reduction, and then oxidation is just the exact opposite. Oxidation is the process of an element or compound. I do apologize for the terrible handwriting, that loses an electron. Okay, it can be more than one electron. Okay, and so something that is losing electrons is being oxidized. Okay, now exactly where the names come from, I don't know. I don't consider it that important, although it might be interesting. Okay, so if you are increasing your negative charge of your element or compound, you are being oxidized. Now, you might just like, what on earth are you talking about? So let me start off by just showing you an example. Let's say we have hydrogen plus oxygen producing water. Okay, just balance this equation. There's two hydrogens here, two hydrogens there, two there, one oxygen, two oxygens. So if I put a 2 here, I'm going to have 2 oxygens, but now 4 hydrogens, so I need to add 2 there so that I have 2 hydrogens again. Okay, excellent. There we go. We've got our balanced equation. The balancing wasn't so important at this stage of the fight, but what I do want to show you is that the oxidation state, or rather the oxidation number of monoatomic, okay, even though this is diatomic, but of a single element. So the oxidation number of a pure element, is 0. Okay, so what is the oxidation number? Well, it's just the charge. It's basically the oxidation number is equal to the charge of a compound. Now, we know that there's 2 oxygens, and since each oxygen actually does have a charge, but they're sharing electrons, as a whole, oxygen here has a 0 charge. Any compound by itself as a whole has a 0 charge, and so if I consider this whole thing, this one's oxidation number is 0. This one's oxidation number as well. The hydrogen as a whole, it is neutral. It doesn't have a positive or negative charge, even though the individual hydrogens might both have charges. As a whole, the compound has a 0 oxidation number. Now, on this side, however, even though I still have 2 hydrogens, okay, in this compound here, Hydrogen, we have 2 hydrogens that have positive charges, and we have 1 oxygen that has a 2 negative charge. Now, where did I get this from? And these are the oxidation numbers, the oxidation number of ions. Okay, in other words, elements or atoms in compounds of ions are equal to their charges. Okay, so it's not very difficult. To be honest, I don't even know why they call it oxidation numbers. Why don't they just keep it as charges? But anyway, they do. And so oxygen is in our periodic table. You'll notice that oxygen is here in the 1, 2, 3, 4, 5, 6th column. Everyone wants to be in the 8th column, so he would love to get 2 electrons. If he does get 2 electrons, he will have a 2 negative charge. Okay, so we'll count the side from which it is the closest. Oxygen is the closest to the right side. To go to the right, I need to gain electrons. If I gain 2 electrons, I'll have a 2 negative charge. While hydrogen, on the other hand, is on the far left. Okay, he also wants to get in the 8th column. Okay, and in order for him to get in the 8th column, it would be easier for him to lose an electron. In other words, to go backwards, even though there's no backwards to go for him. He would go backwards, and if he does go backwards, he would lose an electron, and therefore have a positive charge. So now notice what had happened. We used to have just oxygen itself. And oxygen gained 2 electrons and became oxygen 2 negative. Okay, this is a reverse reaction. Oxygen 2 negative can just become oxygen itself. Now I need to add a 2 there because there was 2 oxygens in the end produced that had 2 negative, but oxygen itself gained 2 electrons. And actually, if I am producing 2 of these, now I actually have 4 electrons there. So I just should fix this. Let me just fix that. That should be a 4. Okay, so a 4. So 2 oxygens would produce, or oxygen itself, a diatomic molecule, would add 4 electrons, and that will produce 2 oxygens that both have 2 negative charges. I hope I'm not confusing you with this 4, etc. Let's just start off by just saying if I had oxygen and I added 2 electrons, it would produce oxygen 2 negative. Okay, but remember, this is only a single molecule of oxygen, and there's 2 molecules, there's 2 atoms there. So the 2 atoms will produce 2 of these. These 2 together will produce this diatomic molecule. And so if this first oxygen needed 2 electrons, then I need another 2 electrons to produce the other oxygen, and therefore that's why I need this to produce with 4 electrons to produce 2 oxygens that has 2 negative charges. Okay, and this is its oxidation number. It has a 2 negative oxidation number. So what had happened to this one? Well, this one we see gained electrons, gains electrons, and therefore oxygen is reduced. Okay, why is it reduced? Because we defined reduction as the process of an element or compound that gains electrons. On the other hand, hydrogen on the other hand used to be H2, and then it became H+, which means it lost electrons, so minus electrons. It produced 2 of these, okay, and so in total on the left hand side it lost 2 electrons to produce 2 of these that were positively charged. Okay, now I do want to just focus your attention on that that you could have written it like this, or you could have said, well, hydrogen became, and this is again, these are reversible, all of these are reversible reactions. You could have written it as like this, and just almost like in maths where you just add this on both sides. You could have said, well, hydrogen became the hydrogen ion plus 2 electrons. In other words, the 2 electrons were donated, and they were donated to oxygen. Isn't that true? Okay, so another thing I just want to show you here is that these two are called half reactions. Half reactions. So half reaction describes the motion of the electrons. In other words, how the electrons were donated and received. And so these are 2 half reactions. Now notice that these 2 half reactions happens at the same time. Now I see that oxygen needs 4 electrons while hydrogen is losing only 2. So in order to use the second half reaction together with the first half reaction, I could just multiply this whole reaction with a 2 everywhere. So this will become 2, this will become 4, and that one will become 4. Okay. And now what I could do is I could say, okay, well now these 2 can be added together. So in other words, I can add these 2 sides together and say 2 hydrogens plus oxygen, and then these 2 added together, because I'm adding 4 and I'm subtracting 4, they get cancelled. Okay, this produces, and then on this side we have 4 hydrogens, but 2 of them are going to combine with these 2. Okay, so I'm going to have already 2 of these. So I've got 2 oxygens, H2O. Okay, so there's my 2 oxygens, and even though there's 4 hydrogens, 2 of them are already in one of the in the molecules, so 2 of the molecules contain the 4 hydrogens. And so this is actually a method of balancing equations, which is brilliant. Here we've got balanced equation, or a method of balancing the equations by trying and to find the balanced electron trading, and that's what's happening here. There's an electron trading happening here. So I think I'll stop the video right here, and then in the coming videos I will look at a few more, just a few more examples of these redox reactions. Thank you for staying tuned, and I hope you enjoyed it and learned something. We'll see you in the next video.